This is AP Physics 2, problem number 20. These are all the algorithms you will need to solve it. However, the most important part to this equation is the force equals, or the sum of all the forces equals the mass times the acceleration. So basically this problem says a block is submerged in a container of liquid and held under a surface by a string connected to the bottom of the container, shown in the figure above. The tension in the string is not zero. How does the buoyant force extend the liquid on the block compared to the block's weight? Okay. So I think the easiest way to explain this would be you have to know a few key things. The block is not moving. Okay? And basically, we know this because the tension in the string is not zero. And if there's tension, that means that in fact the block has to be pulling on the string. And the string obviously isn't detaching from the bottom, so the block isn't going to be going anywhere anytime soon. So what we know is there's a force of gravity on the box, there's a force of tension, and there's also a buoyant force because it's submerged in a fluid. Now we know since it's not moving, acceleration is zero. Therefore, mass times acceleration equals zero. So the sum of all the forces has to equal zero. So far, our equation should be the normal force minus the force due to gravity minus the force of tension, because the force of tension is pulling the block down because it's on the bottom side of the block. Now, if we get all the forces that are acting down on the object, you would put them on the other side. So you would get the normal force is equal to the force of gravity plus the force of tension. And obviously the signs, the negative signs there that were at the beginning, would flip. And since we know the tension is not zero, the force of gravity, or the weight, has to be less than the normal force, given that there's some tension in the string. So now we do know that the answer has to be C, because the weight has to be less than the buoyant force. In some cases, if there wasn't a string there, it would be B, because in order for the block to stay in place, the buoyant force pushing up, or pulling up, I guess you could say, on the block, would be equal to the force pulling it down, gravity. Also, you could say it can't be A with any situation, otherwise the block would be flying out of the water. Or actually it'd be sinking, excuse me. And we also don't know that it can't be D, because it can't be either, depending on the density of the liquid has no correlation to the buoyant force. Also, it says C up there, so I guess I'm right. Ow!